Okay, so this drawing is for a bracket. Got a bracket drawn on the screen. Call it a saddle bracket. Don't know what you want to call it. It's made out of 6mm mild steel, and it's 50mm wide. So what we want to do is to work out the exact cut length right around this bracket, calculate it out, and then work out what our fold points are. It's going to be folded in a press brake with a dogleg blade. Could be done with a straight blade. So we'll turn some information on here. Got some dimensions here. You can see from the overall top line right down to the bottom line, it's 71mm high overall. Let's turn those off. Internally, clearly it's 75mm. From the very end to the inside, we've got a length on both sides of 40mm, so it's uniform. And you will see that in the corner it's got an internal radius, of 8.5mm, which is the same for all of these corners here. Exactly the same. So there's the 6mm on the end for the thickness. So we'll just bring it out a bit. So I've written up the top here, calculating the cut size and the folding positions on a flat bar. So the very first thing we need to know is what V-width size to use for folding the different material. Well, it's going to be mild steel, so the V-width or the opening on top of the V-block for mild steel is always 8 times the material thickness. I'm using 6mm mild steel, so 8 times 6 is 48mm. Just for comparison, if it was stainless steel, the V width for folding stainless steel is 12 times the material thickness because of the higher tensile strength. So we want a V that is very close to 48mm. So we've got a press brake. Here's a chart on a press brake. Going across the chart, this line across here, here's 6mm. We could come down this line here. The V on this side here, V for V, there's the opening on the top of the V. So that width for us needs to be 48mm. So coming down the chart, we've got a 40, we've got a 45, and we've got a 50. We're going to be using the 50mm V. And that tells us that our radius is the 8.5. So just this little drawing here, here's the 8.5 right into the internal corner of the fold. So that's the information we needed. Radius of 8.5 with a 50mm V. And that's why I have drawn it with an 8.5mm radius in that corner. So what we're going to do is we want to calculate this bracket out. So I've drawn up a chart here, calculating lengths and the fold positions. Material thickness is 6mm. V width, as I said, is 50mm. Internal radius of 8.5. So what we need to do is work out how to make a bracket like this, given this information. So one of the things you can do is take your bracket and break it down into its constituent components. It has a straight, then it has a bend, has another straight, it has a bend, a straight, a bend, straight, bend, straight. You can see I've individually labelled them. So that's how we're going to break it down. What have we got on this drawing? Okay, here's all our information. So how do we break the first fold down to get this length A, which was that first coloured portion there? So it's 40mm overall from that outside line to the inside line. That means 40mm would have to take off the material thickness, that's 6mm, and then we'd have to take off the radius. So we're taking off that line distance there. because the straight portion only goes from this blue line on the end here to this line here. That is the straight component right there. So it's 40 minus 6 millimeters minus 8.5 millimeters. So that's how we're going to work out our two straights on either side. Vertically, it's 71 millimeters. What do we need to take off to get the straight line length, which is this portion in here? So what we do is we look at it and we say, well, we've got a material thickness down the bottom here, 6 millimeters, and we've got a radius here of 8.5. So that line is 14.5 millimeters. Up the other end, we've got a material thickness here of 6 millimeters. Sorry, that one there, not that dimension. I'll just flick that back out. So we've got 6 millimeters there, and we've got our radius, which is 8.5. So 6 and 8.5 is 14.5 at that end, 14.5 at this end. And if we take that off our 71, we will get the length for that piece there, which is exactly the same as that length on that side there. So 75 internal from this line to this line here. What do we have to take off? Well, because it's internal, we don't have to take off our material thicknesses. We only have to take off our radius, our 8.5 millimeters, and our 8.5 millimeters on that side off. So our straight line length is going to be 75 millimeters minus 8.5 minus 8.5. So if you can learn to break your drawing down into its constituent straight lines and folds by using that sort of method, you will be able to come to terms with what you're trying to do. Clearly the two reds, the A and the I, are the same colour. They're exactly the same length. The two lime green ones, two vertical lengths, exactly the same colour, same length. The length in the middle is the only one that's that colour, so it's got a unique length. And all four bends, I've got them the same colour because they're all exactly the same size using an 8.5 millimeter radius. So let's go back to our chart on our front sheet. We're going to get the right scale on this. We are. Okay, so what I've done here, I've got my letter codes, which I had here, A, B, C, D, E, F, G, H, I. I got these down the left-hand side. I'll just drop in the pan so you can see the hand. A, B, C, D, E, F, G, H, I. So the very first one, A, I said that was 40 millimeters. Let's go back into it. It's 40 millimeters long from there to there. And we had to take off the material thickness of 6 mils and the radius of 8.5. Drop back out of that, and that's what I've got. I've got 40 millimeters minus 8.5 minus 6 millimeters leaves 25.5. So the A and the I, the two end pieces, if you come down the chart, you'll see that I is exactly the same, 25.5 millimeters, same as A. C and G, they were the two lime green ones, and they were what I said, 71 minus 6 millimeters minus 8.5 minus 6 millimeters minus 8.5. So go back onto the front page. C, you can see what I've done with C. I've got 71 minus 2 times the radius minus 2 times the material thickness, leaves 42 millimeters. So we've got C and G, which are at 42 millimeters. The only last straight line length is E, and that was 75 internal minus a radius and minus a radius. Go back to the front page. E, I've got 75 minus 2 times the radius, leaves us with 58 millimeters. So there's our straight line lengths, A, C, E, G, and I. the next thing we have to do is to work out our corner radius, or our length, sorry, for the corner. Now I've got some more stuff to turn on here if I get my act together. And when we work out our length around the corner, we're working out this mean line. We're not working out the length of the throat line or the heel line. We're working out this line here. So it's 8.5 millimeters plus half the material thickness. So 8.5 plus half the material thickness being 3 is 11.5 millimeters that you can see on the screen there. So into the formula, formula for a corner is 2 times pi times bracket radius 8.5 millimeters plus half the thickness, i.e. 3 millimeters. So all that times together and divided by 4. So by 4 means that it's, 2 times pi times radius plus half thickness is for a 360-degree circle. Well, clearly a corner over here is 1/4 of a circle. So a circle being 360 divided by 4 is giving you a 90-degree corner. So on this calculation here, if we start to put our information in, corner, we've got 2 times pi times 8.5 plus 3. Let's do that on the screen for you. So we've got 2 times, we got pi on here. I didn't even look for pi. So good at making a fool of myself. There's pi times bracket 8.5 plus half the material thickness. So 0.5 times 6 millimeters, close bracket, equals, so that's telling us that it's 72.25 millimeters for a 360-degree circle on that mean line. So we have to divide it by 4 and we get 18.06 millimeters. That's what I've got there, 18.06. I've rounded it to 18 millimeters. You're not going to be working to 0.06. That's going to be an absolute impossibility when you're marking the piece of steel out with a scribe and a square. I could have rounded it to 18.1, but you're not even going to be able to work to that. If you come down here, we've got 25.5. I mean, you can get pretty close to 25.5, so that's acceptable. So I've rounded this to 18. Just get rid of our calculator for a minute. So if you look at our corners, let's go back up into the coloured chart. B, D, F and G. Well, clearly 4 corners at 90 degrees actually add up to 360 degrees. So they are actually make up one circle, but individually on the chart, B is 18, D is 18, F is 18, H is 18. If you add all those dimensions together, I'm not going to do it on the calculator, but if you add them together, you're going to get 265 millimeters. So that's the cut length of the bar that you're going to start with, using an 8.5 millimeter radius with a 50 millimeter V. So I've got this piece of steel here. Well, it's a drawing, of course, but it's effectively a piece of steel. If I click on that and hit properties, and I go in here, you can see that it's sitting here at 265 millimeters long. There's the length, 265. So I've marked it out. So what I'm going to do is I'm now going to turn on some dimensions. Which ones have I got them on? I think they're on layer. So down here, our first dimension, can I get that on the screen all at once? I can, possibly. No, I can't. Yes, I can. You've got good eyes, you know you have. Your first dimension, this length here is A. It's 25 millimeters. The next one is your B. It's 18 millimeters. So I've laid them out. This is A in this box here. Go into pan. This box is A. This split box here is B, this one is C, this is D, E, F, G, H, and I. You add all those dimensions, they're exactly the same as what's in the chart there. So that's how you work out a cut length for a piece of bar. So you've marked your lines on the bar, now you've got to do your folding, and you've got to work out where your fold positions are. So on the next chart here, I've got my bracket. The green line is half the distance around a 90-degree corner, and that's where your press brake blade would come in and hit that dead on that line, and it would fold up halfway either side to give you 90 degrees. So your fold points are half the width of the actual bend, and that's where you're going to start marking them. The computer's frozen for a moment. Now we're away again. Go back to the start. So these lines I've got here, the two red ones and the two come on, it's just freezing a wee bit. The other two lines are exactly in the position of half of that 18mm line there on each one. So in the chart, I put the fold positions for you for this particular bracket. So number one, I'm going to get that on the screen. I've moved it when I shouldn't have. So number one is the length A and half of B. So let's go back to the coloured one. The length of A was 25.5. The length of B around the corner is 18mm. So half of 18mm is 9mm and 25.5. So you can see here I've got A plus half B, 9mm and 25.5mm is 34mm. So that's what's this first line here is going to be from one end. If you actually marked your bar out from both ends, it would be the same distance in from this end as well, but I've actually gone and marked it all from one end. So I'm going to turn some more information here on. What have I got it on? I think I've got it on layers. There we go. Coming in from the end of the bracket, my first fold is 34.5mm. My next fold for number two, fold line number two, if I go back into that last one, so we're working on fold line number two now. So we've got the straight length, we've got a full bend, we've got the straight length, and we've got half the bend. So we've got all of A, all of B, all of C, and half of D. Back into the front. So what have I written here? Number two. I've written A plus B plus C plus half of D is 94.5. So if you add those up, I'm not going to do it on the calculator. You can try it if you want. So coming in from that end, that line from the end to this magenta line here is 94.5mm. Once again, because the bracket is symmetrical, you could actually work from that end as well and mark it off there. And in actual fact, if you did that, you'd have your bracket marked out. But I've worked all from one end. So this next line to this point here, we would have all of A, all of B, all of C, all of D, all of E, and half of F. So if I go into 3, what did I say? All of A, B, C, D, E, and half of F. Add them up the top there, and you get 170.5mm, and that's what I've marked in from the end there. Clearly the last one, do I need to go? I will, just for sake of clarity. All of A, all of B, all of C, all of D, all of E, all of F, all of G, and half of H for the fold line number 4. Back into the front. So number 4 is all of A, B, C, D, E, F, G plus half of H is 230.5mm. That's what I've got there right from the very end to that fold line. So there you go. That's actually effectively already showed you how to mark it out. What am I trying to do here? What I do want to say is if you look at the bracket, this fold here is on the outside and this fold here is on the outside, whereas these two are on the inside. So I have marked the two red lines are the outside and the two magenta lines are as hidden detail. They're on the other side of the bracket, so they are marked on the other side. I'm not sure how many of you have actually folded things up like this, but for your folding, generally what you have to do when you're using a dogleg blade or a standard V block is you need to do fold number 1, fold number 2, go to the outside and do number 4, and come back and finish off on number 3, because the blade needs to get through here on this sort of angle or 45-degree angle to actually do your folding. So it would be 1, 2, 4, and 3 would be your sequence for your folding. So going back onto the front page, what else did I need to turn on? Come on, just get out of there. I've got one other thing, projection lines. If I turn that on, computer's playing up. There we go. So I've actually gone and put my lettering in there for you, just to finish it. There's your A, B, C, D, E, F, G, H, I. All the information there for doing a saddle bracket. I will be putting other brackets up for you to see how they're done. Let's get rid of that, get rid of that, and get rid of that. So I think that's all I need to give you. There's a chart there. I think I've shown you how to go through the chart and do the calculation. This data here, well, there's your standard information. I mean, that's sort of, you know, when you're doing your folding in future, that's the rule of thumb that you'll use. If you're folding mild steel, obviously galvanized Zintex, just standard mild steel, you would have 8 times the width or 8 times the thickness of the material, and that will dictate what size V you're going to use on the V block, which will give you your radius. Dump your radius into the calculation there and half your thickness, and you can work out your corners quite easily. Seems like a lot of information there, but it's quite straightforward. You're really only doing addition and subtraction and multiplication and division. Like all these things, they take a bit of time to get used to. You will make some mistakes at the start, but don't stress about it. Everyone's done that when they've started out in life. And good tradesmen still make mistakes today. But if you can just start to follow that, watch the video a few times, you'll actually do really well, and you'll be miles in front of a lot of the people that you will work with, because so few tradesmen actually know how to mark out brackets like that and fold them up. Generally what they'll do is they'll go to the press, they'll do a couple of folds, they'll do one 90 degrees one way and one the other way, measure it and try and take off the bits and pieces in between. And you know, I call it a cut and patch mentality, just trying to do their best. But it's actually very, very simple if you just take a wee bit of time to sit and concentrate. Keep coming back to the video. I will stick other videos up with different profile brackets explaining exactly the same sort of processes to go through, and hopefully you can start to learn, gain some confidence and strike out boldly yourself. Leave it there. Thank you.